The University of Alaska Southeast Whale Lab has been a leader in long-term environmental monitoring for over 40 years. During this time, we have seen whale numbers increase in a historic recovery and then stall out due to environmental stress of a changing ocean. Since humpback whales feed on small fishes and plankton, studying them provides insight into the overall health of our ocean ecosystems.
Hi everyone, my name is Meg Wright. I serve in Jane Shirley's Whale Lab as an AmeriCorps volunteer. I'm going through the process of learning humpback whale migration patterns, learning how to take pictures of their flukes to understand which whales are moving in and out of Southeast Alaska, and I'm really excited to be here. So today we're going out in the water and we're going to be looking for some whales. We'll be photographing some whale flukes to help identify if they've been in our system before. We're going to run them through Happy Whale, and we're going to do some visual identification to see if we, with our naked eye, can match them on our computer, and that'll help us to understand where they're moving in Sitka and when they've been here in the past. I'm really excited to get out for the first time. I've worked mostly with turtles, with diamondback terrapins, so this will be a first and I'm super pumped.
Okay, so now we've got 2 clear memory cards, and we've got a GPS. I'm going to turn that off until we get out there. Binoculars and data sheets. And then very important, this is our permit.
Yeah.
So this is from NOAA, and it has all the information about how often we can approach whales, which whales we can approach, different things that we can do with different age classes. So if you ever have a question about what we can do, it's all in here. And we have to have it on board while we're doing research.
Gotcha.
So we just keep it back in here. Hi, my name is Ellen Chenoweth, and I'm an affiliate with the UAS Whale Lab. I've been working in the Whale Lab since 2009, and I mostly study humpback whale foraging ecology. We have 3 main data forms that we use. So the first one is the effort form, and we fill one of these out per day. And then the group form is when we actually find a group of humpback whales, we'll start a new group. The last thing is we take photos of individual whales in the group. Professor Jan Straley runs the Whale Lab at the UAS Sitka campus. She has conducted research in Southeast Alaska since 1979. In her lab, we do a lot of different projects, but today we're going to show you and Meg how we do research on humpback whales in Sitka Sound. Today we will be looking for humpback whales in Sitka Sound. Humpback whales are seasonal migrants. These whales are here feeding just prior to their southbound migration to breed in the lower latitudes. We've discovered that 95% of the whales that feed in southeastern Alaska migrate to Hawaii, and about 5% of our whales go to Mexico. We can identify individual whales by using photographs of the black and white pattern of the underside of their tail, known as their flukes. Using photo identification, we can learn a tremendous amount about these whales by creating long-term sighting histories. The focus of our survey today is to find out which whales are here and what they're eating. The best time to see whales in Sitka Sound is in the spring and fall, when whales gather to feed on dense aggregations of herring. Knowing where their food is likely to be is key to finding these whales in a huge ocean. In the fall, usually after a big storm mixes up the water column, herring move into the deep fjords of Sitka Sound and the whales follow. This is why Sitka Whale Fest occurs in the fall each year. In Southeast Alaska, there are 3,000 humpback whales, and about a third of those have been sighted in Sitka Sound at some time. Southeast Alaska is a discrete feeding aggregation with maternally directed fidelity. That means if your mother brings you to Southeast Alaska as a calf, you too will return to Southeast Alaska to feed.
Alright, so for group 1, frames 2 and 3.
Okay.
Frame 4 is the beginning of group 2, the single whale.
Okay.
And then 10 through 14 is group 3.
Okay.
And that's it. We're caught up.
By matching photos of whale flukes between Alaska and Hawaii, we now know that whales can make the trip in about a month. Therefore, if we photograph the same whale twice within 60 days across the winter months, we know that it did not have enough time to make the migration and return, and instead overwintered in Alaska. This is not very common. Most of the time, whales may leave early or late, but only occasionally do they forego their migration altogether. We don't know why a whale may overwinter, but suspect it may be more common in years where food is limited and whales stay to spend more time feeding.
Well, I got that.
Jen Cedarleaf, and I am a research technician in Jan Straley's Whale Lab here at the University of Alaska Southeast. I have been working with Jan since 2000, and I started off just as a volunteer, and worked my way into getting a job, and now I manage Jan's database and photos for humpback whale photos in both Southeast Alaska and Prince William Sound. A whale like this, I would tend to focus on this white spot and maybe that white spot.
Oh.
And I'm not going to look for these marks really because they could be new. And they're, you know, sometimes you only have a photo of a whale that shows this much and we're not going to see that. So if you try to like look at the whole whale and focus on the whole whale, it's really hard. I like to focus on one certain area at a time.
Yeah.
And if it's a dark whale and I'm just looking for the trailing edge, then I might look at, like, say, this little pattern of bumps right there and focus, or look for maybe that, because it's a little different. It just makes it easier if you break it down. There's a lot of whales in this category. We've got 739 in this color.
Oh, there's two
Center
scratches.
whale?
I think so. There's two black marks, I think.
Yeah,
So
and
those,
so
those white marks are totally new.
yeah, they're not there.
So
And
look
so
at
as a double check, I like to just make sure our trailing edge is the same. Swoop, and then there's a high bump. Oh, it's changed a little bit there, it looks like. This is the newer photo. Oh, that's interesting. So that is our IDs over here, 1322.
Okay, 1322.
And so we'll put it right in here. And now it'll be on the photo when we go back.
Wow.
Labels it right there.
Okay, thanks, Jen.
You're welcome.
Hello, my name is Lauren Wild, and I was born and raised here in Sitka. I've been working with Jan Straley's research lab doing humpback whale and sperm whale research since 2007, and I do a variety of work with acoustics, with population dynamics, foraging ecology, and movement of these whales in the Gulf of Alaska. So, what we want to go is a listening device, a speaker to play it through, and then headphones to listen through. It's pretty basic. In order to listen to sound underwater, we use a device called a hydrophone, which is essentially an underwater microphone, and it's about the size of your thumb. We use a variety of different types of hydrophones to locate and record whales underwater. One of the best ways to locate whales underwater is by using a directional hydrophone. The hydrophone is placed in the center of a big dish, and the sound is reflected from inside the dish into the hydrophone to amplify that sound. You place the dish on the end of a long pole and lower it underwater, and as you spin the dish, the sound becomes louder or more faint based on whether or not you have the dish pointed towards or away from the animals that are making the sound. We do this because we don't always know where whales are underwater, so in order to locate and track them easier, if they're vocalizing, you can directionalize that sound underwater before they come up to the surface. And then we also use omnidirectional hydrophones, which is simply a hydrophone that doesn't have anything around it to directionalize sound. So we can lower this underwater and pick up sound from all different directions. These hydrophones can be attached to a cable that leads up to a recording device and a speaker at the surface, so we can listen and record whales and acoustic activity in real time, or we can attach them to underwater housings and place them on what we call autonomous recording devices out in the water for a long period of time, for days or weeks, and record acoustic activity while we aren't there. Those are the main types of hydrophones we use to listen, locate, and record sound underwater. We'll then bring our recordings back to the lab, and we use a variety of acoustic software programs to analyze and learn from the data. These programs all use sound visualization tool called a spectrogram that allows us to see the frequency and the pitch of the sound as well as the energy level or the loudness of the sound. So, let's bring an omnidirectional hydrophone with us. I like this one. So we'll bring that and that. And we've got our honeytone here, and that is kind of our process. So humpback whales produce a variety of sounds, and the three main types of sounds that we humpback whale acousticians categorize are what we call social calls, feeding calls, and song calls. And most people are familiar with humpback whale song, and those are calls that are produced primarily in the breeding grounds. So for us in Southeast Alaska, we often think of Hawaii as one of the major breeding grounds for humpback whales that are in this region. The primary types of calls we hear up here in Southeast Alaska, though, are feeding calls and social calls. And those are produced by both males and females, to the best of our knowledge. And they're produced for a variety of reasons. So I'll cover feeding calls first. Feeding calls are typically produced when animals are, of course, feeding, and they're a very high-pitched wailing sound. Our third type of calls that humpback whales produce are called social calls, and we hear these a lot on the feeding grounds here in Southeast Alaska. There are a variety of different call types, from growls and moans to grunts and upsweeps and shrieks and cries. They're produced as single calls or in groups of calls that we call bouts. And what's really cool about social calls is that they're produced throughout the world, and many of them are the same or very similar across different ocean basins. So we can compare social calls amongst other humpback whale scientists around the world and find many call types that are very similar. We've learned a little bit about these call types, and one thing we know is that they probably serve a variety of purposes, and they're used in many social contexts, such as between mom and calf pairs, or within groups that are feeding, or as a contact call or a group cohesion call. So in terms of underwater soundscapes here in Sitka Sound, when we go out on the boat to do research, we have to be aware of what other sounds are in the water. In Sitka Sound, we have a lot of tourism in the summer, and there's a lot of vessel traffic. There are a lot of recreational boaters, fishing vessels, and there's always some kind of underlying human-produced sound underwater, which we call anthropogenic sound. So those are things to be aware of when we go out on the boat.
We share our oceans with whales and often compete for the same traditional and commercial resources. The UAS Sitka Whale Lab studies how humans and whales interact through our partnerships with fishermen, hatcheries, and larger ocean monitoring programs. We conduct this One Health research because we believe that ocean monitoring is essential to a proactive approach to ensure human and animal health.